Students, before moving forward, let's discuss another example to clarify the concept of Bayes' law even more. So this example says we have to compute the probability of cancer given the test is positive. So by using the Bayes' law, we will have this equation: probability of test positive given cancer into probability of cancer divided by probability of test positive. So here we have this value that is given. Probability of test positive given the person has cancer is 0.9. It means if a person has cancer, there are 90% chances that the report will also be positive. And from this value we can compute this value, that if the person has cancer, the probability of negative report will be 0.1 or 10%. So we subtracted 0.9 from 1 and we got 0.1. So this value is also given. It says given a person doesn't have cancer, the chances of a positive reports are 0.01 or 1%. And by subtracting this value from 1, we will get this value 0.99. So, and this value is also given. It says the probability of cancer is 0.0001. So now we have this value here and this value here, but we do not have this value. And as we discussed earlier, to compute the total probability of a factor, we use the formula of we sum all the probabilities of that factor with all other factors and all other forms. Like if we want to compute the probability of test positive, it will be equal to probability of test positive and cancer plus probability of test positive and no cancer. So probability of test positive and cancer can be written in this form as well by using the formula of probability intersection that we discussed earlier in the video of conditional probability. That was probability of A and B is equal to probability of A given B into B. So by using this formula we get probability of test positive and cancer will be probability of test positive given cancer into probability of cancer plus probability of test positive and no cancer will be probability of test positive given no cancer and probability of no cancer. So by putting these values in this equation we get this value. If you are confused about this formula, you can watch my previous video that is about basic laws of probability, conditional probability and Bayes laws and probability intersection. So we got all these values, and by putting these values in this formula we get this answer, and it is actually 8%. So it is very surprising that given a person has cancer, the probability of a positive report is 0.9. that is very high. So if a person has cancer, there are 90% chances that his report will be positive. But if the report is positive, then there are only 8% chances that he will have cancer. So no need to worry so much if the report is positive, because there are just 8% chances that you have cancer. The report may be positive due to some other reason as well. So this historical data is very important to predict about the future. So that's it. Thanks for watching.